And on that note, can we do something with these cell phones? Just everyone has, and that's all good. I ain't mad at you. But can you either turn it off or put it on airplane mode? It's cool. Or what I do, you know, there's the do not disturb. If you got an iPhone that has a little moon, you can put on do not disturb. That would be really great if you guys could do that right now. I would really appreciate that. And I say that not because I care that somebody's liking your Instagram or something like that. But the fact is, if we're in the middle of doing some gangster math and you feel this in your pocket, you're gonna lose your whole train of thought, right? Because you're like, ooh, somebody just texted me. And you get all excited and you're like, I wonder who did that. You can't wait for the bathroom break and say, I'm gonna check my phone. And then you might do one of these. Right, like this, and you got that obvious suspect face. Come on, man. I've been teaching for 10 years. I know that face. So, yeah, that would be great if we can do that. And then that'll keep from interruptions in the class, and also just to keep you focused, right? We only have 5 days here. I guess we'll have some off-site time at different schools. But I want to do as much as we can right here, right? So let's be on point. Okay, let me hand out the syllabus. We can talk about what's going on in this class. Let's take one passage. All right, I like your enthusiasm, sir. Might as well just read over this thing.
I think we need one more.
Oh, do we?
No. Alright, it's not actually.
Oh, okay. Alright, cool. Thank you. Oh, and you know what? Hand this back to Mr. Sub. Thank you for having the courage to step outside of your comfort zone. Thank you for dedicating time this summer to investing in personal growth and securing a better future for yourself and the ones you love. You have made a large commitment in showing up for this program, and I promise that I will match your commitment and dedication. Calculus Readiness is a non-credited 9-day course designed to strengthen the foundation for your successful completion of calculus in the coming academic school year. We only have 2 hours each day together, so I ask that you are prompt, prepared, and ready to give nothing less than your very best each day. Topics of study include, but are not limited to, function notation, function behavior, rational functions, limits, derivatives, and antiderivatives. And pretty much those last 3 things, that's calculus. Right, that's it. There's a whole lot of details in the mix, but that's it right there. Some basic concepts. Yes, sir. Necessarily, we will strengthen your algebra skills and knowledge of various function types. The amount of material we cover depends entirely upon you. Since you will likely not have time to do homework during your program, so I understand you guys are on the grind all day. That's kind of cool, but so I'm not going to give you homework. We must do all the learning application assessment during our class time together. Grading will be as follows. 50% participation. I'll take attendance each day, make note of your promptness, preparedness, contribution to class discussion, collaboration with peers, engagement, and attitude. Asking questions is a sign that you are engaged in processing new material. Don't be afraid to ask questions at any time. This is a common misconception with most students in the universe. They think asking questions makes you dumb. No, smart people ask questions. Dumb people just sit there and go, and they don't ask any questions ever. Does that make sense? Ask questions. That lets me know that you're using your brain. Okay, 25% is classwork. After we learn a new concept, you have an opportunity to practice applying it right away. Some problems you'll simply attempt in your notebooks. Others you'll complete on a separate sheet of paper and hand it in for grading. And generally for grading classwork and homework, how I operate in, when I teach anything is I want to see that you did the work, right? You're responsible for knowing if you understood it or not, right? Because I'm not going to, if you guys all do a worksheet with 50 problems, like what do I look like grading 5,000 questions, right? And then handing it back, like that's ridiculous. That's not a good use of my time. So do the work, show your work, make sure you're getting it as you go along. If you don't get something, ask a question, like buddy up, work with people around you, and learn it as we go along. That way you hand something in and I'm like, oh, they did it, boom, check mark. And then when we do quizzes, that's when, you know, we can actually grade some and look at, do you understand the material? Does that make sense? Cool. So you guys are responsible for learning, and that's really how it goes. I think that's just a rule that no one can actually teach anyone anything. Like, all knowledge is self-acquired. You have to get it yourself. Right? Like, I can present all kinds of stuff up here, but you have to grab it off of the chalkboard, or grab it from your experience, and make it your own. Right? And that's the way I've always taken learning myself. I went to college for like a decade. Don't ever try that. I don't know. I got a bunch of degrees and certifications and stuff, and man, that's a lot of school. But anyway, I had to make it fun, right? Because if it's not fun, like, I can't do that. You know, just be in a classroom for years. So I make things fun, right? If you're not having fun, you're not doing it right. And so when I take notes, I make them my notes. I don't take notes. I make notes. Right, and I encourage you to do the same thing. If you just Xerox everything that I write on the board into your notebook, you can do that entirely brain dead. You can do that and not actually process it and learn it yourself. Right, so if you're going to write something in your notebooks, like, make your own notes. Right, something that makes sense to you. Does that work? All right, quizzes. A quiz for each topic will be administered and graded in class for immediate feedback. A lot of times I just throw a couple questions on the board. You know, we'll all quiz on a separate sheet of paper, and then we'll trade them with each other and just grade it right on the spot. So you know exactly what you did, you know, what you need more help with. I think that's very effective, that you can see right away, oh man, I'm slipping. I need to, you know, step my game up. These short assessments will help you track your own progress and inform my instruction. Upon completion of the program, each student will receive a letter grade based on the following scale. 90s are A's, 80s are B's, 70s are C's. Is this the grading scale that y'all use at your high schools?
Yeah.
Okay. When I went to school, an A was like a 93 to 100. And then a B was like a 84 to the 92. And so it was different. And so a 70 was a D minus. Now y'all get 60 as a D minus. You're lucky. Yes, sir.
Oh, I was going to say, in some of our classes at Cornwall, we don't have D's. It's just one big C.
Oh, just a large capital C. I've never heard of that. That's interesting. All right. Note that each class will have 2 instructors, myself as well as a support teacher. You may ask either one of us for assistance at any time. We'll be collaborating for planning and grading of this course. We look forward to working with each and every one of you. So, any questions so far? Sweet. The bathroom situation, we have a 2-hour class, right? That's kind of a stretch. So I figured what we can do is maybe after an hour of class, we can have like a 5-minute bathroom break. And I scoped out the situation. If you go straight out here and then turn right where the stairwell is, don't go up the stairs. Go like around the stairs, and then boom, you have men and women bathrooms right there. So they're not far. We can take a break, run and go, handle business, and make it back in 5 minutes. It's good to just stretch after an hour or two. While the blood starts settling in your butt and your brain starts going numb. So we gotta move sometimes. All right, what else should we talk about? Oh, also, I think the deal is, since we're on a college campus with adults, and some of you may or may not be minors. I don't know. We don't need to get all over 18. So what the deal is Mr. Sub will probably have to escort people to the bathroom. Like, if you need to go just by yourself, not during a break time, you're like, Mr. Sub is going to escort you there. During break time, you know, we can all roll there together, and that's cool. And I asked that, please, if you can wait till break time, that would be ideal, right? So, you know, you use the bathroom before class and break time and stuff. That way you don't miss stuff where we're in here But like if you have to go, I'm cool with that. Just give me a heads up. Just let me know. And if I'm like if I'm just about to prove some awesome theorem or something like that, I'm gonna be like, nah, wait one more minute. Like let me finish it. But if we're in a cool spot, I'll be like, yeah, go ahead. So anyway, I hate that when somebody walks out of the room and I'm like, yeah, and I just proved something and it's so amazing, and they missed it and they come back and they're like, what is that? How you do that? And they missed it. I'm like, man, you missed the whole thing. Anyway, we're probably going to use some of these fancy calculators. What you guys know about graphing calculators? You guys use these?
Yeah.
Or something like them?
Yeah.
Does anyone not use one of these graphing calculators? Nice. Bunch of nerds. Look at you. Cool. I like these. These are super powerful. Super powerful. There's a lot of stuff you can do with these. And especially if they have batteries that work. Well, we'll see. When I first got skills on these, and instead of like solving some super gangster equation, I could just type in, just graph both sides of the equation, find the intercept. I was like, what? That's the answer? I felt like I was cheating. I was like, that's it. And but it turns out I wasn't cheating. I was just being smart and using a calculator. Okay. So how many people still need to take the SAT or ACT or any of that stuff?
I need to take it again.
Yeah, I took it 3 times. Yeah. Okay, cool. Those are super useful, right? Solving systems of equations can be this long process, but if you know how to type in a matrix in there, type a few buttons, boom, it spits out the answer. Anyway, so we'll see if we can learn some cool stuff with those calculators. Again, we only have a little bit of time, but we'll see what we can do. Let's talk real quick. The first class, this class, I'm going to talk at you a little bit. Right, I'm going to talk. But I promise we're going to get busy with this math stuff. But I need you guys to be on board with me. So I'm gonna do a little bit of preaching. Here's a question that all of you have asked before, and probably every student that's ever stepped foot in a classroom teaching math. When am I ever going to use this? Yeah, am I right?
Energy right here, right?
Yeah, okay, you guys are like, yeah, when am I going to use this? Right, because, Daphne, do you need to know the quadratic formula to buy some cereal? No. Right, well, you need to know how to differentiate a logarithmic function to pay your light bill? No. Right, exactly, right? So there's a lot of, you're like, when am I ever going to use this? So there's a couple answers to that question. The first one, when are you going to use this? Never if you don't learn it, first of all, right? If you don't learn it, I promise you're not going to use it, right? And that's a neat thing because there's a lot of opportunities, there's doors of opportunity that you won't even see if you don't learn certain skills. And it's not even math, just like if you learn another language, like if y'all learn French or something, and you're in college and there's like a study abroad program to France, you'll see that opportunity. And you'll be like, oh word, I'm going to France. But if you didn't learn French, like you won't even see it because you're like, France, like, I'm not going to France. And you just walk right past that door of opportunity, right? So the more stuff that you learn, the more opportunities you will see in your life. I promise you that. The other answer to when will I ever use this, does anybody go to the gym? Yeah, y'all work out? So you'll see people in the gym doing stuff like this. I promise you will never use that skill ever in your life. No one's ever going to be like, yo, Christian, I need you to just, yo, hold it and do this for me. No one's ever going to ask you to do that, ever. Yeah, that's not a skill that you're ever going to use in your life. But guess what? Going to the gym is what we do to exercise, to grow, to be physically fit, to be active. It makes us stronger, right, by doing these silly activities. So that's what math does for your brain. Math is a brain gym. And so the left side of your brain is your whole logical, decision-making, Take it easy, man. Straight up. He was like, the left side of your brain, it's all your logical, rational, organizational, problem-solving skills. That's all the left side of your brain, and that's where math operates. So we're exercising that, so you get stronger at your logical, decision-making kind of stuff. So the better you are at math, really the better you'll be at logically deciding things about, choosing, am I going to lease a car or rent a car or buy this or Craigslist or just or any, even if it's not a math decision, just any decision that requires rational left brain thought, you're going to be better at doing. You're going to be more skilled and more prepared to jump in and make some decisions if you exercise that side of your brain. Does that make sense? Yeah, brain gym. Yeah, we're gonna do some of this. Here's I'll tell you a little story about that. Anyone ever been to a wedding? And sometimes what they do is when there's a bunch of people that are friends of the bride and groom, they just kind of sit them at the tables, when it's dinner time, and so there's just like a bunch of random people that might not know each other sitting at a table, and so we're like, oh, how do you know, and yeah, silly conversations. And I remember I was sitting at a table, and we're all having this small talk, and this woman, she's a nurse, and she's like, what do you do? I'm a math teacher. And she goes, ew, what do you ever? She says, math, that's crazy. I'm like, man, what's that? And first of all, don't ever do that. Don't ever insult someone's profession. When someone's like, this is what I do, don't be like, that's just rude. Like, why would you do that? But people don't realize that they're being stupid sometimes. But anyway, she's like, when are you going to use that? And yeah, she asked that question, math, when would you use math? And the dude sitting next to me, he was some kind of engineer. He's like, I wish I did know a little bit more math. He said, I'm trying to design this power supply. He worked in some laboratory. And he's like, I don't know if I have the math required to do this. And I'm like, well, hold up. So we're talking, 110 volts, 60 hertz. I said, that's a sinusoidal curve, right? And I was like, I don't know, you're the engineer. I said, but I think the area underneath of that curve is going to be the power output. And if you want to be able to control it, and I said, hold up. And I opened up a napkin, and I was like, look, it's like this. And I graphed it out real quick, and I'm like, yeah, and if you just attenuate this curve, and then, we had it, and we just started getting, he's like, yeah. And we just started getting into it, right? And the nurse is sitting there just like, what's going on here? And so I helped this dude design his power supply. And so she was like, when are you ever going to use this? And I was like, yeah, that's what I'm about to use it right now. That's what I'm going to use it. And she felt real stupid. Yeah, that's a cute little story. When am I going to use this? Shut up. What else are we going to talk about? Okay. What is calculus? Does anyone have any idea what calculus is? Anybody? Any ideas where we're going? This is a kind of math, some level of math. Yeah,
thing that comes after pre-calculus.
All right. You're going places.
Think of the head.
Okay, yeah, that's good. Who else? Ideas about calculus? Janice, did you have your hand up?
I was thinking of something like more like the area or something with the derivative, or like how to find a point between like a derivative or something.
Okay, so there's a lot of details in calculus, but the big picture, it's really all about rates of change in motion and movement, right? There's this dude, Sir Isaac Newton, I don't know, 1690 or something, I don't know, he's dead, no matter, but he was studying physics. He came up with a lot of laws of physics and motion, and he was studying, the motion of planets and their orbits and all kinds of whatnot. And he needed some math that described changing quantities and moving things, right? And so he developed this thing called calculus. So it's all about, it's math in motion. And so it's a little different than everything you've learned so far, right? All this like geometry, there's like the area of a thing that's sitting there. And calculus is more about how would the area of this thing, like how would the surface area of this balloon change as we blew it up and it's growing. What is the rate of change of the surface area as a function of how much air is going into this thing? So it's like another level of complexity, and it's different. You know, it's like you're not in Kansas anymore, right? There's some scary concepts, and there's a lot of fancy notation, right? Where people, there's going to be a lot of scary. You know, you start seeing all kinds of things like this and all these symbols with, you know, different things and what's going on, and you have some whatever going on. And there's symbols, and there's a thing called symbol shock, where students see a bunch of symbols they've never seen before, and they just faint. Right? And they're terrified. But the cool thing, it's nothing to be scared about. Once you understand what the symbol means, you're like, oh, that's not a big deal, right? Like this one, that's a summation. That means add stuff together. Y'all know how to add. Stop playing with me, right? So if it's saying, you know, add e as x goes from 1 to 4. So this is the sum of x's as x goes from 1 to 4. That means x is 1 plus x is 2 plus x is 3 plus x is 4, and then you stop. This is your start. That's your stop. Add them up. Y'all can do that. Right, so once you understand what the symbol means, you're like, oh, that's not that bad. Right, and there's this dude, Einstein, Big Al, I like to call him. He said, math is the poetry of logical ideas. And I dig that, because poetry is like concise, and it's powerful, and when you get it, you're like, oh, wow, I can't believe you just said that. Right, like poetry is a really cool thing. And so math is like that. Math is, anyway. Because you can have some symbols that mean a whole lot, but it's just a few symbols. So yeah, math is pretty cool stuff, and you can get real nerdy about it. That's what I do. So calculus. How do I get ready? Because that's why we're here, right? We're getting ready. You guys are like, what is calculus, and why am I getting ready for it? How do I get ready? So I checked out, probably about half of you took a placement test, and I took a look at those tests, and they were a little rough. They were a little rough, but don't worry about it, right? Because I'm not going to judge you based on, you know, what bubble you filled in, right? And I don't think in the real world anyone's going to judge you based on some standardized test. Right, so I'm not even worried about that. But what we're going to do is take a look at what do we actually need to know to get into calculus. Because there's so much math that we could spend a year teaching all of the things that were on that placement exam. But really, I was thinking about it. I was like, what is absolutely necessary? The main things you need to know is functions, and you need to know algebra. Right, algebra is just the nuts and bolts of how you work with numbers and variables. It's just how you add, subtract, multiply, divide numbers and variables and exponents and stuff. So that's just how you work with it. And so you have to have those skills pretty sharp. You know, like know how to FOIL and factor and, you know, just algebra. And then functions, there's a whole slew of functions. And like I said, calculus is about rates of change and motion and stuff like that. And functions are things that model movement and whatnot. Right. So let's say I throw this in there. What shape is that? Parabola. Boom. Oh, I love this. Right on point. Oh, I like you guys. Okay. So we got a parabola. All right. And the way things move, how about this? Let's give you guys notebooks. Do you guys have like a math notebook, or do you want to use these and this will be your designated math notebook?
Let's use
that.
that.
Let's do this. Okay.
Azul Libra. Right?
If you want to. those out already in case you wanted to write down any of these amazing inspirational things. Taking notes, the way I see taking notes is if you're someone who can take notes or make notes and pay attention and follow along, then go ahead and do that. But if you're somebody who, when you're taking notes, like all you're doing is focusing on the writing of the note and you're not like mentally available for processing stuff, then don't worry so much about taking the notes. Okay? And you may be somewhere in between. Does that make sense?
Yeah.
Because I'd rather you guys follow along and be with me on these concepts than like have a pretty notebook. Right? Yeah. So gravity makes parabolas. Right? That's a quadratic function right there. Kind of cool, huh? So things moving are functions. And if you get into a little bit of physics, and this is something like, again, you can write this or not write this. Like, you know, you can just watch. The height of a thrown object. So this is a parabola, and I already said it's a quadratic function. Is that a positive or a negative quadratic function?
Negative.
Yeah, that's right. It's going down. So it's going to be a negative x squared, but it's a function of time. Has anyone taken physics or took physics?
Okay.
Okay. Nice. All right, so this might not be new stuff to you. So you got negative half the acceleration due to gravity times time squared, plus you got an initial velocity times time, plus the initial height. And that's going to give you this parabola. It's quadratic. And then if you, and let's say the height of this pen that I threw, let's say this is in feet, my units. And if I want to know the rate of change of this, that's going to be the velocity function, right? This is a height function. And, in feet, velocity will be feet per second. So what is the speed of this thing? I don't want to throw that out, it'll explode. But it starts off fast, slows down to 0, and then negative velocity on its way back down.
Acceleration.
Well, that's where we're going next. So if you know some calculus, you take the derivative of this, which means find the rate of change of this, and you end up with a velocity function, right? And then so you end up with negative the force of gravity times time plus the initial velocity, and you end up with something in feet per second, right? The rate of change of this distance we call height, distance over time, feet per second. Then you take the derivative of that to find the rate of change of velocity. So let's say my velocity is 10 feet per second, and then I speed up to 20 feet per second. My rate of change, my velocity has changed. So my feet per second increased over a period of a second. So I've increased 10 feet per second. If I went from 10 to 20, so it sounds a little crazy, 10 feet per second. But what is that? Acceleration. So the acceleration due to gravity, we take this derivative and we end up with, we get this constant because things have a constant acceleration because gravity is constant all day long, and it doesn't change for us. But anyway, so we get these, and then, so feet per second, we call that feet per second squared. And that's another thing where you might be like, second squared. But it means feet per second. And then, so we take derivatives, and you might not even know what it means, and that's fine. But you're going to get there eventually. We take the derivative to find the rate of change to get here, and then we take the antiderivative, which is the integral. You may have heard, and that's this fancy thing here, that big old S. Ooh, fancy. We integrate to go backwards, right? And it turns out that finding the integral of something is equivalent to the area under the curve. So if I have, and this is groovy right here. This is just a sneak preview right here. If I know the velocity if I have a velocity function here as a function of time, and say, start off at 0 feet per second, and something speeds up, and then it's going at a constant velocity, and then it slows down and it stops. If I take the integral of this velocity function, it gives me the area under the curve, and the area under the velocity curve is equal to the total distance I've traveled. What? Think about that. Like, the area of that is equal to the distance that I've traveled. Calculus is kind of cool. Not gonna lie, it's kind of cool. And also, let's say for instance, if I wanted, if somebody said, hey, find the maximum height of this thing that I tossed up in the air, I could solve this quadratic equation. I could use some symmetry here. Say, it took 6 seconds for this thing to hit the ground. I could split it in half and say, I bet at 3 seconds we got a maximum height. And I could plug this in. I guess that's not that difficult. But say I didn't have some symmetry. Let's say I threw this thing off of a cliff. Don't do that, that's dangerous. So if I don't have symmetry, I don't even know where the middle is. And someone's like, hey, what's the maximum height of that thing? And I have this quadratic equation, and I have to solve for some maximum height, and it could get burly. But if I know calculus and I take the derivative of this and I have the velocity function, I know right here the velocity is 0. Smell me? It goes up and then it stops, it's not moving, and then it comes back down. So I can set this linear equation, set it equal to 0, and solve it. That's real easy. Boom, I know the time when it reaches maximum height. Right, so calculus is kind of useful. It's kind of nifty. And I would like for you all to be successful when you get there. Now, let's talk about functions. When I look at the placement exams, I don't know what that really tells me. It gives me a general idea, right? But I threw this pen in the air, and homegirl was like, "That's a parabola." Right, so you guys are smart. Everybody knew that. You guys are smart. I know this, and I need to gauge how much we need to cover before we get into calculus. I just want to make sure we're solid with our functions and solid with our algebra, and we can get started on calculus ASAP. Right, to give you some of the big pictures and concepts of calculus, because I want you to go into calculus. Like I said, it's a different kind of math. And if I prepare you guys and expose you to some of the calculus ideas, you'll go into calculus confident, and you'll be solid, and you'll be like, yeah, I got the rate of change. Boom, I got this. And if we don't do that, you guys will see the symbols, you'll be scared, you'll be like, oh, don't get calculus. And then you're gonna stop, and then you're gonna struggle, or not. Maybe that'll be simple. Anyway. So let's talk about functions. Let's get it in. Let's talk about functions, and then we'll see. I need to get a sense of where you guys are. If we need to polish up our function skills, we will do that, and if not, we'll keep it moving. So let's. Any questions or anything so far? How we doing out there? Am I going too fast? I talk like a maniac sometimes. We good? Yeah. Okay. What kind of functions do we know about? Anybody? Janice?
The absolute value one.
Oh, I love that function. Absolute value function. Yeah, let's jot these down real quick. The absolute value function looks like y equals absolute value of x. It's like a field goal or something. And what does the graph of that thing look like? It's a V. Yeah, okay. Lovely. Somebody else. What's another function, Christian? Square root. Square root function. Yeah, or we could just say roots. There's different root functions. Ooh, maybe I shouldn't be saying y. Should I be saying f of x? You're ever talking about functions, huh? Yeah. Look at me, I'm slipping. talking to? You stopped doing that years ago. Okay, f of x equals square root of x. You can even do, g of x is the cube root of x. Fourth root, fifth root, all that stuff. Square root function. Anybody know what that curve looks like with that graph? Square root function. Yeah, like that. It's well, really, it's half of a sideways parabola. Did you guys know that? Okay, cool. Because it's the inverse of x squared, which means switch all the x and y values. So it's like a parabola, but this is not technically a function if we draw the whole parabola.
It doesn't pass the line test.
That's my girl right there. It doesn't pass the vertical line test, so we had to get rid of this. That way each x value would have exactly one y value, which is the definition of a function. So yeah, so that's why the square root function looks like this. And then a cube root function, what do you think?
Oh,
Like
cube
another
is
curve.
not like this?
Oh,
That one? Like x to the third, isn't it when it's like, I don't know.
Oh, that's x cubed, but the cube root. Yeah, you got it. It looks very similar to that, but so square root, we can't take the square root of a negative number without getting imaginary numbers. Ooh. But we can take the cube root of -8, which is what?
-2.
Yeah. All right. So yeah, this one goes over this way. Cool. All right, we got some root functions. Who else knows another function? Helen.
Log function.
Log function.
Yeah.
Yeah. Function. Logarithmic functions. Yeah. So f of x is log of x, or even we can say the natural log. No additives or preservatives. It's all natural. What's that curve look like? Anybody?
It's like decreasing. It's like curved down.
It's similar. It's the opposite of an exponential curve.
So it's not?
The inverses. So it's like a sideways exponential. So let me write exponential because we let that cat out of the bag. Exponential function. Let's say we have f of x is 10 to the power of x, and I think most people know what an exponential function is because it's like population growth. Right, like it starts off low, and there's this horizontal asymptote. You guys cool with that word?
Yeah.
All right. And then it grows crazy like that. And so if we do the inverse of this, do you guys know how to tell inverse functions if you see them both graphed?
All of the x and y are switched.
Yes, the x's and y's are switched. So if this is going to be my exponential, what's another way to say the x's and y's are switched? What's another way that you can look at this and tell there's some kind of symmetry?
Y equals x line.
Yes, the y equals x line, like this. And the inverse function, any inverse function, should mirror that. So approaching horizontal asymptote, this is going to have a vertical asymptote. It's going to do the same business. So inverses will do that. Right, you'll get the symmetry. So so exponential, you know what it is. If you know what that is, you know what a log function is. Boom. Other functions. Linear functions. Cool. I like those. Linear functions. Yeah, we'll write that. I was just thinking linear functions fall into another category of functions. That's your mx plus b stuff. That's linear, a line. But what category do linear functions fall under? There's like a family of functions. Quadratic is in the family. That's baby brother. So quadratic, I'll write quadratic.
Cubic.
Yeah, you guys know the family. You guys are acquainted. X squared. And the shape of that, that's a Parabola, like they call it in Texas. Yeah, somebody say cubic. Right? So that's your x cubed. That's this guy. All these are a certain kind of function. Ooh, come on, you got it. I know you got it. It's in there.
Cosine and sine.
Hey, you're changing the topic, all right? What? And then you have quartic. Who said it? Oh, well, you cheated. You went to UCLA. They're polynomial functions.
Oh.
These are all polynomial functions. Yes. Oh, see, everybody knew it. Y'all are just holding out. These are all polynomial functions. Polynomial functions. All these here. Yeah. I guess I didn't draw this in the right way. You know what I mean. Yeah, they're all polynomial functions. Yeah, and then there's quartic, quintic, and then, you know, x to the 5, x to the 6, x to the 7. You can just keep going. But those are all a big family of functions. Yes, ma'am.
How is a linear polynomial?
Okay. Polynomial functions are functions where you add, subtract, or multiply numbers, variables, and positive integer exponents. You're not dividing by x, and you don't have any decimal exponents. So this is similar to this, and this. These are all in the same category, right? And this is your linear, your parent function. So yeah, I mean that's. I don't know if I explained that well. Does that make sense? That they're all in the same category because there's no, once you square root a thing or you divide by x, because then you might divide by 0 and, you know, put a hole in the universe. You know what I mean? You can't do that. So that's a different kind of function altogether. And actually, let's talk about that. What happens if you do start dividing by x? What kind of functions are those called?
Rational?
Oh my God, you're so nice. John, these, man, woo, hot. Okay, rational functions. He's on fire. Rational functions, that's where you take a polynomial function divided by another polynomial function, essentially. So a rational function, we'll get fancy, say r of x is some polynomial function divided by another polynomial function. And this is, wherever this bottom function equals 0, you end up with a vertical asymptote or a hole in the graph or some unexplained supernatural phenomenon. You know, there's like a spirit. There's these crazy things happen around divide by zeros, right? Black holes, explosions, right? Not bad things happen to good people. So we don't divide by 0. But what do those functions look like?
Doesn't it depend?
Yeah. You got it. So yeah, this is your general. This guy. This is your 1 over x is the great grandpappy of all rational functions. What's that called? That shape? No.
Oh, the shape.
Anyone know that shape?
M. Oh,
Called a hyperbola? No? Hyperbola? Okay, anyway. Hyperbola. It's kind of nifty. Anyway, it's like a parabola on energy drinks. It's a hyperbola? Come on, that was original material. Okay. Rational functions. So, those are interesting. Those are very interesting, and we'll probably take a look at those because they kind of lead us into this idea of limits that we're going to get into for calculus. What are some other functions? Yeah, trig functions. Sine, cosine, tangent, irrational. Trig functions. your sine of x, cosine of x, tangent of x, and then you guys know some other trig functions?
Cosecant, secant, cotangent.
All right, yeah, the reciprocal trig functions. So that's your secant, cosecant, cotangent. And then you have inverse trig functions too, right? Inverse sine, inverse cosine. You guys with those?
Yeah.
All right. You guys are on point. Okay, we're going places. I'm excited. Okay, now yeah, going to Silicon Valley. All right, so this is beautiful. Oh, and these trig functions, yeah, this is you know your sine function, sinusoidal,
Wave.
and then